Hey everyone, if you'll allow me 5 minutes of your time, then I'd like to tell you the sad but potentially happy ending story of data on the environment. Come with me on the journey through time and space, from the 1800s to a not so distant future in the 2050s, so we can explore a new pathway to shared environmental data. But first, let's go back to the 1800s. To a time when scientists began to systematically observe the environment with some basic instruments, so that they could improve our knowledge about the world and translate that knowledge into maps. The increased capacities of mankind made it possible to send people and satellites into space. For the first time, we were able to observe our planet from space, which should have been enough to realise the true limits of the planet on which we lived. So we live in a world with a huge amount of information on the environment, but a development pattern that is not taking this depth of knowledge into account. So most of the valuable information coming from Earth observation is sent to the trash can. Hold on, we've come to the most complex part of the presentation. In order to connect data providers with data users, special data infrastructures, or SDIs, use web services for vector and raster data. First, data providers create and publish metadata, a standardized description of the data, and data itself. The important web services encountered here are named WMS, WCS, or WFS. We'll find out what they stand for on the next slide. Then, data users discover the published data in the metadata catalog in order to finally access the data itself through web services that feed into several types of clients, such as personal computer and internet web mapping applications, or mobile devices such as cell phones and tablets. The standards most used for web applications are WMS for image services, WCS for gridded data services, and WFS for vector data services. Let's look at WMS image services in more detail with an example from the Preview project on natural risks. Let's focus on Australia to explore the WMS services published by Preview, with a simple internet address to share customized maps as images for flooding hazards, forest fire hazards, and cyclone hazards. By connecting data with users and contributing to international initiatives through web services, SDI built on open standards can help bridge the gap between policy and science. SDI can also help integrate knowledge from different disciplines in order to create more scientifically based decision processes. The challenge is to move from scattered, unused, and expensive databases to distributed, accessible, and standardized web services. Let's see, for instance, what happens when a user asks to the Water Information System for Europe, WISE, what's the water quality of European rivers? WISE is based on SDI technology and connects up national databases to provide information at the European level in a standardized way. WISE queries the SDI and publishes a map on its data portal to answer the question. The same thing happens when a user asks the Biodiversity Information System for Europe, BIS, where are the natural reserves in Europe? The answer to this question is also generated as a map on the BIS data portal. With these two examples, we see how SDIs help in answering specific end-user questions through retrieving on-demand persuasive maps with up-to-date information. This represents a much more efficient way of spending public money, especially in a time of repeated national debt crises. WISE and BIS show how the same data can be shared by different systems for different purposes using web service interfaces and open standards for information exchange. The idea is to create each dataset once and reuse it as many times as possible. What's going to happen in the near future? We believe that mankind needs to reconcile Earth observation with its activities and therefore with its decision-making processes. For a more sustainable future, we need to make better use of our knowledge. We need searchable and easily accessible data on our environment to favour a more democratic understanding of the complex environmental and societal issues. We want to be able to explore the past, the present, and the future of our planet, because we've only got one, and as it belongs to nobody, it belongs to everybody. We still have a choice. Will we choose the wiser path? If we do, it might still be possible to aim at a more sustainable future for our generation and our children. To reach a more sustainable world, we need to work together and start taking the sharing and processing of crucial data on our environment seriously.